Good morning, everyone. Myself Gautam Sharma, a mechanical engineer, and today I have come here to teach you a thermodynamics or basic thermodynamics. So today I will make you understand how thermodynamics works. What exactly the thermodynamics is, so you need to know that. Okay, so thermodynamics is the branch of study which deals with the heat exchange from and one body to another and conversion of heat energy into mechanical energy, right? So suppose this is a body 1 and this is a body 2, right? So this is a body 1 and this is your body 2, okay? So when there is an exchange of heat, suppose heat gets transferred from this to this portion, then what will happen? So there may be a change in the form of energy. Suppose gets converted into mechanical form of energy. So how this heat energy gets converted into mechanical energy? So we will do study step by step. Okay. At first, I will teach you about the thermodynamic system. What is exactly the thermodynamic system? Okay. So thermodynamic system. Suppose thermodynamic system, right? Thermodynamic system. Suppose this is a portion, okay? So a portion where our focus is made and to study its volume, either its temperature or pressure, its states, okay? So when we confine some space, when we do study in a confined state, then this confined state is known as system. Basically, thermodynamic system, we have to study about its volume, temperature and pressure, okay? So this is your thermodynamic system. So how many types of systems are there? So there are three types of systems. First of all, there is an open system. Second is closed system, and third is isolated system. Isolated system. Isolated system. So one by one, what is open system? Suppose a body is there or a system is there. There is an exchange of heat, there is an exchange of work, there is an exchange of mass. Okay, when there is an exchange of heat as well as mass transfers occur, then this type of system is known as open system. Can you relate this? For example, suppose water is flowing into this system. Okay, so see here, when water gets entered, it means that mass gets enters and water get exit from this system, water exits, it means that mass gets transferred. As well as it is not an insulated system, so heat may go inside the system or heat may come inside the system. So this type of system is known as open system. Now we will come across a closed system. Suppose this is a closed system. How you will define this closed system? In this closed system, no mass transfer are there. Mass transfer is not there. There is no mass transfer, right? How we can say that there is no mass transfer? See here. Suppose this is a piston and cylinder, right? You know about IC engine. I think you are already familiar with the IC engine. So IC engine work on the expansion of a gas. Suppose this is a gas. Okay. When this gas expands, so there is no mass transfer. There is no mass coming out of the system. Only heat is going into the system or coming out of the system. So this type of system is known as closed system. Okay. So I think open system you have already cleared. You have already understand open system, closed system, and third is your isolated system. What is isolated system? So let it be clear that isolation means what? I think everyone knows about the in a corona time, we have already come across this word that patient had been isolated. Isolated means what? There is no exchange of either food or commodity. But in this case, there is neither transfer of mass. See here, isolated system, isolated system. Okay, so no mass transfer occur. No mass transfer is not occurring. no mass transfer, no heat transfer or energy, any form of energy, no heat transfer are there. Can you see any example of an isolated system? So there is an example. I think everyone knows about thermoflask. Thermoflask, what does it do? See here. Suppose this is a thermoflask, okay? So when you keep a hot tea, it remain hot for a certain time. Why this happens? Because there is no exchange of heat. So this is an isolated system, and already you know that there is no mass transfer also. Okay? If you put cold water for certain period or for a long hour, you will see that there is no temperature decrement in the coldness of the water. Why this happened? Because it is an isolated system. It is an isolated system, right? So three type of system I have already taught you. Okay. Now I will talk to you, teach you a thermodynamics work. Thermodynamic work. Okay. What is thermodynamic work? See a thermodynamic work. Now let us consider a piston in cylinder. Already, if you want to learn more about thermodynamics, so you have to use this example again and again so that you will be able to understand in a more frequent and more lucid manner, right? So this is your piston. See, what is piston? You already know. You have seen, I think you have seen in so many TV ads that piston is moving up and down in a cylinder of an engine. Engine oil advertisement I think you have seen. Okay. Now see here. This is your gas. Okay. Gas. Okay. Now pressure of gas. Let us consider the pressure of gas is P. P is your pressure of gas. Pressure. And V is your volume. V is your volume. Okay. V is your volume. And piston cylinder, it is like that. When you see top view, it is a circular way. Okay, circular. It's like, see here, it's like this shape. Okay, this shape, right? See here. So when the gas expand, what will happen? So the area. Let us show you an area of this piston. So area of this piston is A. Okay. When gas expand due to high pressure, when you heat it and it expands, so it comes forward like this. Okay. This piston move upward direction. In upward direction, this piston will shift by the distance of suppose x. Okay. Now tell me, when this piston goes up, then there is a shift of a volume. Okay, swept volume. It is your swept volume. So can you tell me what is the volume which is displaced or swept volume? V equal to as area into x. Okay. Now we know that work done is equal to what? Now tell me, work done. We already know or we already familiar with these things. Work equal to force into displacement. Okay, force into displacement. F into S. This is your displacement. This is your displacement. Okay, and this is your force. Now, in this case, you have seen that this is your pressure P and the cross section area of the piston is A. Okay, then the force acting on this piston will be what? So we know that force by area is your pressure. So force equal to pressure into area. So we can write here pressure into area into S is what displacement here. Displacement, what is the displacement? X. X is your displacement. So X is your displacement. Now we can see here that P is your pressure, A and X is your area into X. So this will be volume. So work can be written as P into V. Okay. So thermodynamic work. So thermodynamic works. Whenever you come across this type of things, then if you want to find the work in a thermodynamic system, then you have to write like this. Okay. but it is a basic formula. But when you go for a higher thermodynamics, then you don't use this formula. You always use integration method. Integration, what is integration? Suppose this force may vary, pressure may vary. So force and displacement, if it is constant, if force is constant, then it is okay to use. But when we come across the practical situation or practical scenario, then this formula won't work. So what we have to do? We need to use an integration method, right? What is an integration method? So see here, work. Suppose dw, small work is done. Whenever we use integration method, so we will use only small thing, dw, dx, and this displacement may be written as dx, right? So dw equal to pressure into dx, we can write like this. Okay? No, sorry. So pressure into dx, no, we can't write this. We can write this dw equal to, since it is your small work, so we have to write like this: pressure into area into, there is a dx displacement. So this can be written as like this. Okay. So area into dx will be change in volume, because this volume, earlier this was volume V1. Now after final position we got volume V2. So change in volume will be dV. So we can write this P into dV. Okay. So this is your dW. Now this is a small work and we don't know about the change in a pressure. So we need to integrate both the side. Integrate both the side, right? Integrate both the side. Both the side. So if you integrate both the side, so dw equal to integration P dV. So actually work done, net work done or total work done will be equal to integration pressure into dV. So this is your basic standard formula and it will work everywhere. Okay. So for a higher studies or for a high level or for 11th class or 12th class, if you go to find out the thermodynamics work, then we have to use this formula only. Okay. And if there is a constant pressure and constant volume, then simply we use this formula. So try to use this formula for each and every process. Okay. Now I will teach you about thermodynamic process. What are the thermodynamic process you need to know? Okay. Suppose this is a system having a state 1. Okay. It has a volume V1. It has pressure P1 and it has a temperature T1. Okay. Now if this system gets an external energy, whatever it may be, a heat, or removes heat from this, or there is an work done on the system or work done by the system, then there will be change in its state of either volume will be changed, either pressure will be changed, or either temperature will be changed. Okay. So this states, when this state change gets changed, then it follows the rules of equation of states, that is Pv equal to mRT, right? Where according to this formula it will start changing. Okay. So this is state 1 and this is state 2. Okay. This is state 2 and it has pressure P2, it has pressure volume V2 and it has a temperature T2. So when this system undergoes from state 1 to state 2, then this mid portion is known as system is undergoing some process and we don't know which process is going on. So we have to find which type of process are there. So I will teach you each and every types of process and you will be able to understand that this process is what, either isobaric process or isochoric process. So you need to understand step by step. So equation of state is very important. Okay, according to this equation of state, all the gas gets governed. All the gas will follow this equation. Okay, this is general gas equation. We can say that this is a general gas equation, right? Now see here. So you have already understood that it is a state. This system is in a state of 1, that is pressure P1, volume V1, and temperature T1. And this system is having a pressure P2, volume V2, and temperature T2. Okay. And when this system undergoes from state 1 to state 2, then in between this is known as process. Okay. Suppose if we follow this diagram, see here, if we follow this diagram, this is your pressure volume graph. So graph volume is denoted in an x-axis and pressure is denoted in a y-axis. Okay, and the situation of state or if you want to represent state 1, then suppose this is your state 1 having a pressure P1, having pressure P1 and volume V1, right? So it may, this system may undergoes after the process, it become it comes to the state of 2. So there will be a pressure P2, there will be a pressure P2 and there will be a volume P2. Okay, so this is known as process. Okay, now I will teach you subcategories of this process. Okay, how many types of process are there? Okay, and how work will you will able to find out what is the work done. Okay, now first of all I will teach you about isochoric process. Isochoric process. Okay, isochoric means what? Volume remain constant, V equal to C. When we put in the equation PV equal to mRT, then what will happen? You know that P is variable. P is variable means P varies, but volume does not varies because it is the constant volume process. If you will draw the diagram of piston cylinder, then what will happen? You just put a stopper. Okay, whenever you will give either heat or whatever you will give, there will be no change of volume. See here, it is a constant because there is an stopper. Okay, so there is an stopper, so there is no change in a volume. So this process, when you heat this system, so there will be a change of internal energy, there will be a change of pressure, there will be a change of a temperature, but you will not able to see here there is a change of any type of volume. Okay, so this type of process is called isochoric process. Okay, see here, P by T equal to mR by V. Okay, where a mass, universal gas constant and volume remain constant. So P by T is written as constant, or we can write here P1 by T1 is equal to P2 by T2, right? And this is equal to P3 by T3. So we can write this equation like this. Okay, so this is the thing. So isochoric process, I think you have understood. Now the question is that how you will able to find out work done. So I have already taught you what is the formula of work done. So work done is equal to integration of P into dV. Okay, that is integration of P into dV. Now when this piston cylinder having state 1 to state 2 process is undergoing in from state 1 to state 2. So please see here how we can represent this process in the PV diagram. See here. So you are telling, or I am telling, that volume is constant. So suppose state 1 is here, state 1 state 1 is here, state 1. Okay, and it comes to state 2 when you apply a heat, then it becomes state 2. See here, this is your straight line, right? Straight line means what? State 1 has volume V1 and state 2 has also volume V2. So volume does not get strength after applying any type of heat or applying a work. Okay, but there is a change in a pressure, that is P2, and there is a change in a pressure, that is P1. Okay, so work done will be what? See here, work done is equal to PdV. So work done is equal to PdV, but there is a change when a volume is 0. So in this case work done, we can write here work done is equal to 0. Okay, now I think you have understood about isochoric process. Now I will teach you about isobaric process. Bar, you understand, I think everyone knows about bar. Okay, bar is the unit of I think pressure, right? So bar is the unit of pressure. Okay, so you have understood what I mean. So iso means what? Constant. So you can remember like this. Okay, isobaric process. Isobaric process. What is isobaric process? Isobaric means what? Pressure remain constant. How will you understand this thing, that how pressure will remain constant? So suppose there is a system. Same, you have to use, always try to use this piston cylinder, because you will able to understand that what exactly is happening. Okay, because it is the best example, I think. So there is a gas. Okay, and it is in a state 1. State 1 means what? It has pressure P1, volume V1 and temperature T1. Now you are telling that isobaric process, that is pressure remain constant. So when you heat, suppose you are heating this piston or cylinder, so there will be a change in a pressure. But you are saying that pressure is constant. It means what? Cylinder or piston will go upward to continue or to make the pressure constant. Okay, in this way pressure will remain constant. So P1 will be equal to, after in state of 2, P1 becomes P1 because there is no change in the pressure, but volume may increase, temperature may decrease or increase, we don't know. Okay, again we need to use the state, that is we use equation of state, that is equal to PV equal to MRT. Okay, so here you can see here PV equal to MRT. Now what will happen? Again you see that pressure is constant, right? If pressure is constant, then what will happen? So V by T equal to MR by T. You can write this. So V by T equal to MR by T, sorry. So pressure is constant, so we can write this equation V by T equal to constant, or you can write this V1 by T1 equal to V2 by T2. Okay. Now, how will you find the work done in the isobaric system? See here, work done in an isobaric system. So again we use dW equal to into PdV, or work done equal to integration of PdV, right? So we can use these things. Work done is equal to integration PdV. Okay. Now you tell me, pressure is constant. So as per the integration rule, if any terms is constant, so we can write it outside. So integration dV. So volume is changing from V1 to V2. So we can write lower limit V1 and upper limit V2. So work done will be equal to what? Pressure P into V2 minus V1. So this is the formula of work done for isobaric process. Now the thing is that how will you represent this isobaric process in PV diagram? Okay. So suppose this is your pressure and this is your volume. Okay. If this is your pressure and this is your volume, then in PV diagram, how will you represent? I think you have already understood that how to write this. Suppose there is a pressure P1 and P1 V1 and P1 V1 and T1 is the state 1. Okay. Now after a while, where this point I can write, so I may write here, but you know that pressure is constant. So where I have to write, see here. If you put this straight line, then 1 to 2. See here, pressure remain constant because P1 equal to P2. But what happens? Volume changes. Volume become V1 to V2. So here, volume become V1 to V2, but pressure remain constant. I think this is all about isobaric process. So I hope you have understand each and every part. Okay. If you have any type of problem, then you can make ask again and again what type of concept you